All right, so now we're going to look at strategic behavior, which we've talked about arises out of oligopoly because there's so few firms, and how it relates to something called game theory, which maybe you've heard something about before, but we're going to talk about strategic behavior and game theory in this section. So when we're trying to explain the pricing and output behavior of oligopoly markets, we're basically talking about something called a reaction function, which is really at the heart of the interdependence going on in these types of industries. And it's kind of like what I was talking about earlier with best responses, right? If my competition in the oligopolistic industry does this, what is the best thing for me to do in response to what they're doing? That's what basically a reaction function is. It's telling me how I should react given what my competition does, right? So it's basically a function, and the input is my competition's actions, and it gives me output telling me what my best action is, what my best reaction is, or my best response is. Okay, so the reaction function is the manner in which one oligopolist reacts to a change in price, output, or quality made by some other oligopolist in the industry. And this is coming out of what's a branch of mathematics actually called game theory that is commonly used in economics. So game theory is a way of describing the various possible outcomes in any situation involving two or more interacting individuals when those individuals are aware of the interactive nature of their situation and they make plans accordingly according to some reaction function. And the plans that are made by these individuals are known as game strategies. So the reaction function is providing the individuals with their strategies. Oops. Now, there's different types of games that individuals can be a part of. There are cooperative games and there are non-cooperative games. A cooperative game is a game in which the players explicitly cooperate to make themselves better off. And examples of these are collusion of firms for higher than competitive rates of return. So this is what we're going to talk about with cartels. There are also non-cooperative games, which are games in which players neither negotiate nor cooperate in any way. Relatively few firms and each have some ability to change price might be an example where non-cooperative games come into play. So it's going to look like what we are going to talk about is a cooperative type of game, but it's actually, as it turns out, non-cooperative. You'll see what I'm talking about. But just to give you some other examples in real life, a cooperative game would be like any team sport like football or baseball where the players on a given team need to coordinate and cooperate together in order to win the game. Whereas a non-cooperative game would be something like two players in a game of chess, right? There's no way or reason for them to cooperate in any way, assuming, right, the normal standard rules of chess. They just want to beat one another, right? So there's no rhyme or reason for cooperation in a game of chess like there is within a team in a game of football, right? And there's also something called a zero-sum game, which is kind of related to these ideas. But this is basically a game in which any gains within the group are exactly offset by equal losses by the end of the game. So tic-tac-toe is an example, right? If you play tic-tac-toe, there's really only three outcomes, I guess, or two, depending on how you look at it. But it's either player A wins and player B loses, or player B wins and player A loses, or there's a tie, right? And so in that sense, it's a zero-sum game because a tie is basically no one wins. So there's no gains, there's no losses though. Or someone wins and someone loses. So there's a gain and there's a loss, and they exactly equally offset one another. Another example would be gambling at a slot machine. So as you're gambling and putting money in, if you lose that money, it's a gain for the casino. And if you win any money, it's a loss for the casino, and they're exactly offsetting one another. And so in that sense, playing a slot machine is a zero-sum game as well. Now, there are also negative-sum games and positive-sum games. A negative-sum game is a game in which players as a group lose at the end. Let's see. This would be... I'm trying to think of a good example, and there aren't a lot of examples of negative-sum games. Maybe a game of chicken, if you guys know what chicken is. It's when two drivers drive directly head-on towards one another, and the players can either swerve and avoid a collision, or they can collide with one another. So there's different outcomes in that game. One outcome is that neither player swerves and they hit each other head on, in which case clearly both players lose. Another outcome is they both swerve, and so while they do avoid colliding, they both look like chickens because they both swerved, so they still are both losing. And then the other outcomes are one swerves and the other doesn't, so one looks like a chicken and loses, the other that didn't swerve wins, essentially, because they didn't chicken out. But that outcome, there's a zero sum there, right? So in that sense, the game overall is still negative, because even when someone wins, it entails someone else losing. So in those outcomes, there's a zero sum, because there's a winner and a loser in that case. But in the other outcomes, either where both swerve or neither swerve and they collide, those are both negative sum outcomes. So chicken is a negative sum game. Then there's positive sum games where there are strictly gains overall. So it's a game in which players as a group are better off at the end of the game. This would be a game of battle of the sexes, perhaps. But in any case, it's when there are positive gains overall to be had. That'd be a positive sum game. All right, so we're really only going to be concentrating on non-cooperative games. So let's talk about strategies in non-cooperative games. So a strategy is basically just a rule that is used to make a choice, such as always pick heads, right? That could be a strategy if you're playing, if you're flipping a coin, right? That could be a strategy. Another strategy could be always pick tails. Yet another strategy could be alternate between picking heads and picking tails. There are, potentially large number of strategies. In some games, there are a limited number of strategies. And we'll see a particular game where we'll look at how it has a fixed set of strategies. And then there's something called dominant strategies, or a dominant strategy. And a dominant strategy is a strategy that always yields the best payoff or the best benefit. And so regardless of what happens, you should always pick it. Okay, so that's what a dominant strategy is. It's basically the strategy you always want to pick. So we'll see these in a second. All right, but first let's look at a behavioral example. Why there is a 50-50 chance that cheating on one's mate is a dominant strategy. So according to game theory, the counteracting benefits and costs for males and females to engage in multiple sexual relationships should lead to an outcome in which about half of males and half of females engage in multiple sexual relationships. And this prediction actually closely matches the biological evidence. So this is pretty interesting. I'd like to find out what papers or what research this is referring to, but pretty interesting findings. So basically what this is saying is that there's a game theoretical prediction that 50% of males and females should cheat, and that prediction actually closely matches the biological evidence that exists. So pretty interesting behavioral example.